Yeah, once again, welcome to another session. Today we are going to answer some questions from the recent paper of the senior certificate in assistance of those who need of some of the explanations in the paper, and also just clarifications, especially in preparation for the June exam, and also trial and the final. So this is a very important session that we'll be having. Please pay attention to details, and then so that you can approach the upcoming examinations at least with better view of some paper 1 questions. We'll start with the multiple choice question, which is the first question. In this case, we are given this question 1 multiple choice. I hope by 1.1, a book rests on a table. Which one of the following forces will form an action-reaction pair with the weight of the book? Firstly, we must know what is the weight of the book. If we know that the weight of the book, by definition, it's the force that the earth exerts on every object above its surface, and in this case, which means that now the weight of the book will be the force that the earth exerts on the book. Therefore, the Newton 3 pair of the weight of the book will be now the force that the book exerts on earth. So the best option there will be the force of the book on earth, which is B. That is the best option. 1.2, a person is standing on a bathroom scale on a moving lift. Which one of the following motion of the lift will result in the smallest reading on the scale? Smallest reading meaning that now the tension will be smaller than the weight. So in this case, we know that if the lift is going upward, the tension obviously is bigger than the weight. If the lift is stationary, the tension is equal to the weight. Or if the lift is moving at constant velocity, whether up or down, then tension and weight are equal, according to Newton 1. Therefore, the only case where now the tension will be smaller than the weight will be when the lift is accelerating downwards. And that now the net force is in the direction of the weight. So which one is the case in this one? Then it will be when the lift is accelerating downwards. That is number B again. Fine. We come to number 1.3. Look at this one. They say the velocity versus time sketch graph below represent the motion of a ball which was in free fall. The ball strikes the ground after t seconds. Strike the ground after 3t seconds. Yes. And then which of the following statement is correct? If we strike the ground here, and that it was coming at t, we know that velocity is 0. Therefore, it's when it was at the maximum, and that the ball was released at least at a height above the ground. Then we look at that one. The ball was dropped, no. From a height above the ground, no. The ball was thrown vertically upwards above the ground, no. And then the ball was thrown vertically upwards from a height above the ground. That's a perfect one. So the answer will be number C. And then we move on with this answering these questions, and then these are the next ones that are following. One of the best question papers of late. This is the case. Now 1.4. In 1.4 they say the vector diagram below shows the initial momentum P1 and the final momentum P2, and the change in momentum delta P for a car that moved on a straight horizontal road. In best ways, we say normally if you want to master the momentum cases, it's better if you now do it in this fashion, to say when you are drawing the delta P, you start with the initial, which is P1 in this case. So, and then also the final one will start at the same point. Then what happens, this one will give, this is P2. Then the final will be when you join in the initial to the final. Then this will be the delta P, will be this one. You join the head of the initial to the head of the final. Now in this case, it shows that the initial momentum is bigger than the final momentum, but they are heading in the same direction, meaning that now velocity was decreased here, or the momentum decreased. Now we look at this given graphs, which one will represent the better one, where momentum gets smaller but in the same direction. So the best option will be number A. That's the case. So best option is A. The stone of mass M is dropped from a height above height h above the ground. Ignore the effects of air friction. Which one of the following combination in the table below correctly represent the kinetic and the total mechanical energy of the stone at the instant the stone has fallen through a quarter of the height? We know that according to this one, if we elaborate here to say, if it's at the height here, the highest point, where is height h, we know that now the mechanical energy here is totally potential. Why? Because the kinetic energy and potential energy as the mechanical energy, there is no kinetic energy because it's released from rest. Therefore, mechanical energy becomes mgh. Therefore, if it has fallen a quarter of that height, somewhere here, so which means that now at that point, remember the mechanical energy is still kinetic energy plus potential energy, fine, which is mgh, fine. Now they say in this case, which one of the following combination will be the case? Now it means that if it has fallen that one, mechanical energy now is 1/4 mgh, fine. What about the kinetic energy? For you to give you mgh, therefore the kinetic energy must be now a third quarter of that mgh now, because this plus this will give you 1. That's the best option now. Therefore, which one of this will be the case? According to this one, we check the kinetic energy in this case will be 3/4 mgh, and whereas the mechanical energy still remain mgh. Therefore, C becomes the best option. The next one, which is 1.6, let's look at this one. They say to us, the spectrum of helium emitted from a star moving away from Earth is compared to the spectrum of helium found on Earth. Remember, when we move away, that's your redshift. Therefore, in redshift, you must know that when we talk about the redshifted stuff here, therefore, in a redshift, in a nutshell, just to give you some points, the movement is away, yes, and then the frequency will be smaller, and then the wavelength will be higher. I think that's what we are looking for, because Doppler is about these three: motion, frequency, and wavelength. Then we are looking for that one. The observed spectral lines from the moving star will have a lower frequency, yes. We are looking for lower frequency. The answer is between A and B, and then but the wavelength must be longer, not shorter. Therefore, A becomes the best bet. Fine. We come to this one. They say to us, the magnitude of the electric field generated by different point charges are measured at a fixed point. For each measurement, the distance between the fixed point and the charges are the same. Which one of the following sketches graphs correctly shows the relationship between the magnitude of the electric field E and the magnitude of the charge? Remember, we have got this for your information. E equals to KQ over R squared. Therefore, the relationship between E and Q, they are directly proportional. You can see from here. Therefore, we are looking for the graph which shows a direct proportion between the two. Therefore, again, 1.7a will be the suitable answer in this case. Now, let's go to electric circuits. Again, they say here, in the electric circuits here, the diagram below, represent the circuit in which the external resistors have the same resistance. Now all external resistors are the same. Fine. You can see what is given here. Fine. You can see that A1, in this case A1 and A4 are equal, whereas now A2 plus A3, they give you what? A1 or A4. But if you look at this one, the resistance in the A3 is bigger than the resistance in the A2. Therefore, A2 will carry more current than A3. So A3 will be the least here. Which one of the ammeters will have the lowest reading? We've already analyzed, then it's A3. So C becomes the best bet in this case. We come to this one of a simplified diagram. In this case of electrical machine is shown here. Now we look at this electrical machine. Obviously it's a DC. If you look at that one, and if it's DC, it becomes a motor, because you have to supply the current here so that the coil can turn. Then becomes this one a motor, a DC motor. Now what type of machine is this one? A DC motor. That's number 1.9a. Thank you. Then the last question in this case, wrapping up the multiple choice. This is the photoelectric effect question. Now they say, which one of the following combinations is correct for a line absorption spectrum in terms of the energy transition of the atoms and the appearance of the narrow lines in the spectrum? Remember, in this case of absorption, we say absorption is normally if we've got energy levels. Let's say we've got energy level 2, energy level 1, energy level 0, no problem. Then the absorption is when now the electron is gaining energy from radiation and then jump into this one. So it does absorption, whereas emission will be when it drops down. In that the transition will be from the lower energy level to higher. And then in terms of the spectral lines now, on the screen, then you will have a full colorful rainbow colors, and then but with dark lines. So I think you're looking for that. So colorful spectrum with dark lines, then that is the case. Colorful background with dark lines, then you're looking for that one. Energy transition should be from lower to higher, and that it's between B and C. And then whereas the appearance, it should be the now not colored lines but the dark lines. So the answer would be C. That is 10C. Thank you. That is the multiple choice. Very good. And let's pause, and then we'll start with question number 2 now onwards, which is your Newton's second law. Newton's second law, that's question number 2. So let's meet in the next session.